There's a lot of finesse that's required when operating in the head, neck, and in the ear. There's a lot of cranial nerves, a lot of functional organs, and it's a very small space. And for example, in an ear, when we do a reconstruction of hearing bones, we really measure a prosthesis or an ossicular prosthesis in fractions of a millimeter. And those make a difference between good hearing and not so good hearing. So it really requires a lot of finesse. And a lot of the patients that get treated by an ENT are related to quality of life issues, whether it be facial plastic surgery, whether it be nasal breathing, whether it be hearing, those sort of things. So all of those fascinated me, and the finesse surgery, and also the ability to do auditory neuroscience. I'm extremely fortunate to have this supplement from the ACS and the Trilogic Society to help me increase the number of people in my laboratory. We study a gene that's one of the more common genetic causes of both congenital, meaning when people are born, and also age-related hearing loss. And this gene was discovered in 2001, like over 20 years ago. And no one knows what it does. We know that it's required for hearing, but no one actually knows what its function is. In our grant, we show preliminary data that we've discovered how this gene is working in the ear. We're sort of the first lab to sort of discover this mechanism of this gene. It's been sort of an enigma for the last 2 decades. This was a capstone onto an award I had from the NIH K08 award, which is a mentored grant that's 5 years long for junior clinician scientists. The supplement from the College of Surgeons and the Trilogic Society provided me extra funding, which really allowed me to increase the number of people in my laboratory, which increases the productivity of the laboratory and allows me additional time outside of the clinic to really think and write papers and write grants. So it gives me that sort of intellectual time to do the work.